So I'm done with the first semester of my engineering courses. And I have to say, to some extent, I feel a little bit strange. I feel a little bit unfulfilled. Um, Everything went well. It was a very busy semester. I took a lot of classes, more than 5, and one less than 10. So I took a lot of classes, and everything went well. But, a part of me still feels unfulfilled in some ways. And I'm trying to figure that out. Because you think, getting things done, things are going right. And all that's good, but I think through this first semester I'm experiencing exactly the reasons why I'm setting out to do a lot of things I'm doing with regard to engineering and curriculum, and why I even make some of these videos, why I have this channel, why I'm incorporating a kind of revision towards engineering education as part of a section in my PhD project. Before I touch on that, I want to talk about a previous video that I made having to do with Ramanujan, the mathematician Ramanujan, who was a self-studied individual who contributed to the field of pure mathematics. And I made a video. In that video, the point in that video was to say, don't sell yourself short. You don't know where your own studies are going to take you. You don't know where your own pursuits are going to take you and what they're going to end up. So, pursue your own unique interests, just as Ramanujan did. Ramanujan could have been great at math. I don't know if he really was, or if he had a natural ability. Maybe he did, but maybe his natural ability was some kind of creativity, or maybe he just had a knack for asking good questions. Maybe that's what drew him to pure mathematics. Lots of people that are good at math don't do anything in math. Or you ever think about that? A lot of people that are good at things don't necessarily contribute to the field, or try to, or see themselves in that way. People that contribute to their field are usually somebody who has some kind of unique perspective or unique question, unique attitude towards it that ends up doing something. Which is why I think it was important to mention Ramanujan, especially in a context like this where we have a bunch of non-traditional people, because if you're going out and looking for other disciplines to learn about, or wanting to obtain more information about something that you're not privy to, and that makes you unique in a lot of ways. And this channel is not meant to be a motivational channel. It's not meant to be something where I'm trying to, again, influence people. But in some ways I am. I do actually absolutely want to influence you to, keep striving and keep learning, and keep with the project of self-improvement, because I feel like that's exactly what this is all about. It's all about improvement at the end of the day, self-improvement. It's not really about electronics. It's not about math. It's about self-improvement. And it's self-improvement by way of doing mathematics, self-improvement by way of doing electronics, okay? Self-improvement by way of appealing to your intellectual interests. I think one of the reasons why I'm kind of lackluster, I don't know, not disappointed, I wouldn't say disappointed, but just kind of like not that thrilled about how everything went during the course of my semester, and just my education and the engineering program, is that I feel like a lot of it wasn't practical enough. I think it obfuscates the aspect of creativity in the curriculum. And I'm not the first person to say this. And I understand, some people might say, and I think they're correct to a degree, to say, well, school's not for that. School is just to do the classes to get your certificate, and that's exactly why I'm doing it. I like to learn. I like education, but I'm doing it specifically, to be able to get licensed. That's really the only reason. That's one of the primary reasons. So it's more of a legality in a sense, the legal requirement than it is a personal aspiration. Because of course, you can just learn what you want to learn outside of a traditional academic setting. But again, like I said, I've really witnessed through this experience all the reasons why I'm so passionate about coming up with alternative methods of education, especially within STEM fields, because I see there's such a lack of applied pedagogy. And I don't feel as though, I feel like you can be put into the position of where, and this is very much how I felt, and I think this is where my feelings are coming from. I feel very much you can get put into this position where you are, you're having to prove yourself through curriculum, but you're never working on like real world problems, real world issues, and real world things that you yourself are trying to solve. Okay? You're not working on real world things that you yourself are trying to solve or want to solve. We're just given a bunch of curriculum. And let me explain too the issue with that. It's not just that you're not doing real practical things that would be more productive in the end, but it's also that you're not really employing the mind of an engineer while you're in engineer training, let's say, right? While you're being trained to be an engineer, while you're in an engineering degree program, it's almost like you're outside of engineering. It's such this weird thing where it's like you're supposed to be in it, but it's almost as if you're outside of it, analyzing and playing with different pieces of knowledge that have to do with engineering, but you're not doing engineering, and you're not exercising the thinking that you would if you were engineering something. And the reason why I know that is because I do engineering all the time, not just in the sense of this channel or in electronics, but, living on the farm, I design and build things all the time. And to be quite frank, agriculture and farming is actually systems engineering. You ever think of that? You ever think of it like that? I tell that to people quite often, and I think sometimes, they're like, a light bulb goes off a little bit. I'm like, yeah, this is systems engineering. It's not like hanging out with animals. It's not, just the bucolic house on the prairie kind of thing, rural living. I guess that's an aspect to it in a sense, or if that's a perspective, but really, farming is systems engineering. And then with that, at one level it's systems engineering, and at the global level, at the macro level. And then on the micro level, you have infrastructure engineering, right, which gets into your structural and civil, because you have to have infrastructure for your animals, right? And then you have the whole kind of economic engineering bit, because you have to make a product, and your product has to be viable to sell and all that kind of thing. Then you have like the logistical engineering part of it. How do you grow and process and package and produce and sell your product, right? So there's logistics involved. So you have all the layers, very many layers of engineering within the enterprise of agriculture and farming. So I do this kind of stuff all the time. And, I guess I feel sort of embittered by the fact that I'm in this engineering program doing something that's good for me in the long run. It's good for me. It's good for me. It's good for my business. It's good for my future. But it's also taking a lot of time away from me doing the real work that I need to be doing. It's actually taking, my engineering degree is actually taking me away from doing actual engineering, which is like, it's just a funny thing. Just a funny thing. I just feel like so much of life today, for so whatever reason, it always seems to be backwards like that, you know. It's kind of that whole thing of it's like Mike Rowe all over again, right? And I love Mike Rowe. I love the fact that he pushes for technical education, vocational education, that he pushes for skills, closing the skills gap, getting people more into the trades and all that. I think that's great. I love it. I'm a big fan of his. But this very much speaks to exactly the kind of situation that he talks about, and it's kind of like I feel like I'm getting it from both ends. I'm seeing it from both ends, and being in a unique position of kind of experiencing both of the things at the same time. That is, being someone who's in the world on the ground, practicing trades and skills, techniques, and everything like that. But then also being on the academic side of a technical degree, no less, but then also seeing that it's so much less productive. And I'm not saying that academia is less productive, but the scheme of engineering curriculum is less productive and less applied than it could be. The reason why I say academia isn't productive, because part of my woes in this situation is actually not just that I'm not having enough time to do the engineering, but which is, the real stuff that I have to do on the farm, the real stuff I'm trying to build, the real stuff I'm designing, the real stuff that I'm trying to bring to fruition, the real stuff that's going to make a difference on my farm, in my business, in my future. But then the real stuff also that I'm not pertaining to actually in academia on the humanities side. You see, all my other academic work having to do with the social sciences, okay, which is very important work. And then all the academic work that I focused on in the philosophy of science, which has to do with the philosophy of physics and epistemology and all that kind of thing, which is a very fervent conversation today. It's very pertinent conversation today. So this is one reason why I'm very anxious in a certain way to get to my PhD work, which is on the horizon. But I'm just dying in some ways to get back to doing real work. Getting back to doing real work. I just said this to see, people don't understand sometimes maybe how valuable certain things are. People sometimes they poo-poo education or academia, but I'm telling you, I'm the significance of my PhD work compared to the significance of my bachelor's in engineering there's no comparison. There's no comparison. And I understand it. And this also gives me another perspective, having, I have a bachelor's already, obviously, then, I have a master's, and I'm preparing to do my PhD, and to being on that sector, that side of academia, and knowing that kind of work and that kind of rigor that it takes to do that kind of stuff and what's expected of you. Because when you're at the graduate level, you're treated as a peer, and you're also in a situation of curating or discovering or putting together new knowledge and asking new questions, divulging new information. On the bachelor's level, we're just doing a bunch of stuff that's already been done, and it's not that interesting. We're doing even some stuff that's like, it could even be questionable. It's like, it's not even, is that really what it is? Is that, I understand. It's like, engineering program, we're learning everything is about Newtonian physics, but Newtonian physics is being challenged all the time now with quantum physics. So it's like, half the stuff we're talking about that we're taking as the literal truth of the universe. If just a little bit beyond that, that there's very much a question to whether that's the literal truth of the universe. So it's like some of the stuff we're learning isn't even. I'm not going to say it's not real. I know it's real and it's a perspective and it's something that works. Newtonian physics works, yes, but there's challenges to it. There's other perspectives. There's a broader conversation around it. So again, I guess it's a feeling of feeling like you're almost being misled, or you're only given a little bit. You're only given a little bit of the discussion. These things are very broad and very deep, but in the setting of a bachelor's degree, you're only given you're not even asked to ask questions. That's, I guess, maybe that's probably um my trepidation here. Me coming from the graduate level, humanities, social sciences, philosophy of science, philosophy of physics, I'm more apt to being a proponent in the discourse. When you're in an engineering program, you're not a proponent in the discourse. It's just like, hey, do these problems, and they're just arbitrary problems. They're not even problems that apply to anything that we're trying to figure out today necessarily. No, they're problems. They're problems that we know we can figure out and have figured out a long time ago. And it's like it's not interesting. You know. Now there's something to be said to being proficient. Of course, that's what I'm saying. It's a necessary evil. I'm not saying it shouldn't exist. My take on what should really be happening, and this is something that I'm pushing for on my PhD project, is that I feel like engineering programs should be more applied. So let's say instead of just taking a bunch of general classes, I'm not talking about gen ed. I'm talking about like your actual core classes for engineering. Instead of taking those general classes that you have as your core classes, why don't you come into the program with the idea that you're going to solve either a problem that exists in the world, or a problem that exists in a company that you want to build, or a problem that exists in a product that you're trying to make. And then you going to school facilitates you embarking on that problem to find a solution for it amongst your peers and the faculty members in which you're a part of in that university. And it's a collaborative effort with the students and with the faculty to actually solve problems and make something or create something. I'm using these broad terms because you don't always make a product in engineering. Like I said, it could be something like agriculture, which is like systems engineering. Engineering can involve schemas, right? Just like industrial engineering, right? Processes, schemas, processes, manufacturing, all this kind of thing. It doesn't necessarily have to be like a product, And if you didn't have something unique enough, perhaps you could partner up with one of your peers and help them on something if they had something that was like a large project that wasn't something that they could do on their own. You see, and I think something like this could even really have a future and a place in MBA programs more specifically, because it would be tailored to more entrepreneurial engineers who wanted to start a business or start some kind of enterprise. And they would be able to create that enterprise, perfect that enterprise, come up with business plans, economic analysis, production styles and routines, manufacturing processes, all these kind of things you'd figure out in those 3-4 years that you're there doing that. And you'd have experts, the faculty members there to guide you and to help you with this process. The only reason why I feel like this doesn't happen or doesn't work is that it would be too successful, right? It's like I feel like in a certain way, school is there, like I said, to kind of weed people out or to try to gatekeep people away from participating, rather than having a collaborative participation where we're not only wanting to get that individual student across the line, we're wanting to collaborate and push the human enterprise forward. Okay. It's just my thought, just a thought. This is actually something I'm working on, and yeah, I've just noticed that, you know, I'm seeing why this is so relevant. So how does that relate to everything that we're doing here, and how does that relate to you guys? And how does this relate to Ramanujan? It relates in this fashion. Don't give up your creativity and your personal motivation and pursuits. That's why I made the video about Ramanujan. That was the point of that. And again, I want to reiterate that to you because this is important. This is part of what I'm saying, and part of what I'm experiencing is that the engineering program isn't going to do everything. Getting your degree isn't going to do everything. Getting the license isn't going to do everything. If you're someone with ideas, you have to divulge your ideas. You have to develop your ideas. You got to make your ideas. And sometimes, unfortunately, you have to do that against the grain or against, the establishment, not in a rebellious sense or an antagonistic sense. I just mean, unfortunately, a lot of institutions that we have and establishments that we have that you would think would be there to help you through these things don't really help. They're just set up to do their processes and to do their certifications and to do their credentialing, and then you have to go do your own thing. But what I'm saying is it's extremely important, at this point where it seems like a lot of us are, because there's a lot of people that follow this channel who are just like me, who are doing this as a second career, or as their second bachelor's or something later in life, or a personal project or something that they, there's an individualistic element to why they're doing this. It's not just like their first rodeo. It's not their first degree. It's not their first time. It's someone who's coming back and who has a purpose. So this is my point, just like Ramanujan had a purpose with his interest in mathematics. If you have a purpose in this engineering, if you have the purpose in learning electronics, don't wait to accomplish that and embark on that because you're getting your degree, or because you're waiting for me to put out a video, or because another YouTuber hasn't put out this, or you haven't found the right book or whatever. Work on your problems, work on it, find solutions, build what you're going to build, have fun through the process. I just cannot stress to you enough how much more valuable all that is than doing all the credentialing stuff. Necessarily evil. It has to happen. I'm not trying to say it's a bad thing. It's not a bad thing. It's just, it's like 1/10 of what really matters. And people say that all the time. I read a post the other day about engineering specifically, and they said, well, we only use about 10% of what you learn in school. It's very common that engineers have that perspective. You only learn 10%. You only use 10% of what you learn in school in the actual field. That's what I mean. I'm saying that if you really want to have an edge or advantage, the advantage is that you already know what you want, and you need to pursue what you want. You already know the project that you want to build. You already know the kind of thing that you want to do. You need to go ahead and pursue that, and not wait too much for the next course or to learn this or that. Do some self-study. Keep creating what you're trying to create. What you're creating matters more than all the credentialing and all the little things behind it. This is also why you might notice that a lot of my videos are practical based. I'm not trying to give you what you can find in a book somewhere. Sometimes I look at some of the videos and I'm like, oh man, I could make this more technical or put this and add this, and because I like to do that stuff. But at the same time, I realize how unimportant a lot of that stuff is. And this is part of the message I'm trying to send to you. A lot of the minutia, a lot of the other stuff involved in it, a lot of the technical stuff isn't really, it really isn't, it's not the goal. The goal is the manifestation. Okay. Just like in the case of engineering, we use math not to just do math. We use math to make predictions and to have ideas about how things are going to come out, you know, um, whether something's within a certain limit, okay, whether something's within a certain tolerance, whether something is going to fit in the right place at the, whether something is going to, let's say in the case of electronics, if a voltage is going to rise at a certain time, at a certain period, and all this kind of thing, right? We use that so we can understand and know how things are going to function before we build them, so they have more of a likelihood of success when we do build them, because building something takes time and money. It's why we do all the calculations. It's why we do all this stuff, to save us the trouble of wasting time and money in the end. Because some things can't be done by trial and error. Okay. Like I was thinking about this earlier. Think about this example I was thinking about earlier. Give it the example of like a substation. Substations are huge and dangerous. They cost a lot of money. They're dangerous things. We can't just, trial and error how to make a substation. We got to figure out basically precisely how that substation needs to be made before we make it, because it costs too much to forge all the steel that's going to make the transformers and everything else, and assemble all that stuff and get it all organized to then see if it's going to work or whatever, right? You can't do that. You can't do that in every situation. Some things have to be figured out beforehand. So the design process is where we get into the minutiae, where we get into the numbers, where we get into the theory, where we get into all that stuff. But that's not the point of it. The point of it is to have the final product. So what I'm saying to you is that you already have the final product. You and your pursuits is the final product. You and your imagination, your creativity, the thing that you have in the back of your head that you want to create is the end product. Okay, the end product isn't just to, go to school or to get this credential and to say you have it. The end product is actually making something out of what you already have in your head that you're trying to bring into fruition. So focus on trying to bring that into fruition. Don't be too much distracted into the technical stuff. The technical stuff can help. It's going to help you, but that's all it's there for. It's just there to help you, when pen comes to paper. But in the end, you want to manifest and build what you're building and, get it out there. So anyway, that's my message to you all today. Have a good one. Leave some comments. I hope you're enjoying everything, and we'll keep pushing. Have a good one.